Hi, boys and girls. All right, we'll make this graph or this video a little bit faster. I think this time. I already have the graph drawn for you, so you don't have to watch me do that part. But just remember that it's really important to draw your numbers or write your numbers right on the lines. See how my one is directly on top of that one. I'm gonna move over here a little so maybe it won't be so blurry, right? You've got to make sure that you write right on the line. And remember that this zero represents zero distance and zero time. Now, my next data table is for the fast constant, which you can see right here. Right there it is. All right. And I already know that, okay, so first of all, it only took us 7 seconds. So I really don't need all of this space right here. So I'm just going to go ahead and put my seconds in. 1, 2, and also writing right on the line, not in the spaces. 3, 4, 5, 6, 7. I might make it go 8, 9, 10, even though I don't need those extra seconds. And now I'm going to take my data table and turn it into coordinates. All right, remember that the x coordinate is always the time coordinate, x, right? And that the y coordinate, time, okay, so is the distance coordinate is the y, which is why I set up the data table this way with time first to make it easier to make our coordinates. All right, so our first coordinate is 0, 0. Our second coordinate, which you guys can't see right now, I realize that. See that now? Let me really put this up higher. Our second coordinate is 1, 1, which means that Nick was at 1 second at 1 meter. The next coordinate is 2, 2. So in the second, he was at the second meter. Then 3, 3. So he's going about 1 meter per second. That making some sense right there? If every second he travels 1 meter. Then the next one was the fourth meter. He was still on the 3rd second, so he sped up there just a little bit. It's going to look like he stopped, but he didn't. All right, and then the next one is at the 4 seconds. At 4 seconds, he was at the 5th meter, and at 5 seconds, he was at the 6th meter, and at 6 seconds, he was at the 7th meter, and at the 7th meter, he was 8th meter, he was at 7 seconds. All right, so now it's just a matter of graphing all of our data, our coordinates. All right, and let's get that done now. Get all my chords out of the way. All right, the first coordinate is 0, 0. So remember, that's right here at this corner. 0 distance and 0 time. Our second coordinate, oh, and also keep in mind that for the first coordinate, we go to the right and then we go up. Crawl before you climb. So the next one is 1, 1. Over 1, up 1. Crawl 1, climb 1. The next one is 2, 2. Crawl 2, climb 2. The next one is 3, 3. Crawl 3, climb 3. The next one is 3, 4. Wait a minute. Oh, 3, 4. Yeah. All right, the next one is 4, 5. Over 4, up 5. So you see there was a little increase in speed right there. Over 5, up 6. And then over 6, up 7. And then over 7, up 8. All right. And my goal here was to show you what it would look like if your speed was increased. So what I'm going to do is just kind of mark it from the beginning to the end and show you what the line would probably look like. All right, I also would like to compare the last graph with you, which was a little more medium, but really not all that different. So see how this graph was a little bit lower. Like the slope of the graph was not quite as steep as over here. Can you see that? Right? So this one was my fast constant. You can see that because of our data collection, or else Nick's walking, we have a little bit of an issue, but it's essentially a little bit steeper, which would be a fast constant speed. Because it forms a diagonal. I keep doing constant. Constant. This would be a fast constant because it's more steep, right? And what it really means is this. Look how on the first graph, Nick did 8 meters, and then in the second graph, Nick did 8 meters too. But in this graph on the right, it took him 11 seconds to go 8 meters because he went at a slower speed. And in this graph, it only took him 7 seconds to go the same distance. So remember, when you go the same distance, but you do it in a shorter amount of time, then you have a faster speed. Let's say that again. When you go the same distance, but do it in a quicker amount of time, you have a faster speed, and that makes your line slant on a distance time graph get steeper. So whenever you're looking at a distance time graph and you see a steep diagonal, you can tell that they were going pretty fast, right? The steeper the diagonal, the faster the speed. All right, I think we'll stop right there. Good job, y'all. Good job, Mrs. G. All right, let me see, where's my thing so I can stop this. Where'd I go? Yeah.